Welcome. We are beginning Unit 1, Arithmetic and Algebra Essentials. And the first section that we're going to cover is R1 on the real numbers. We'll only cover two objectives in this section. That is Objective 3 and 4, Evaluate Numerical Expressions, and Work with Properties of Real Numbers. All right, let's get started with some examples. So to begin, numerical expressions, the big idea is order of operations. Maybe you've heard, please excuse my dear Aunt Sally, or PEMDAS. That stands for parentheses, exponents, multiplication, division, addition, subtraction. That's the order in which we should do arithmetic. So here's an example, 2 times 5 plus 2 times 10 minus 3 squared. Let's get through it. We begin with parentheses. So the first thing I want to evaluate is the 10 minus 3. I'll write down everything again, 2 times 5 plus 2 times, but then the parentheses evaluate to 7, and I keep the square there. You might wonder, well, should I maybe multiply the 2 times 7 together first and then square that? No. Do your exponents next. So 2 times 5 plus 2 times, and I take care of the exponent. 7 squared is 49. And now I can move on to multiplication. I have 2 times 5, that reduces to 10, and 2 times 49, that's 98. Those are added together. Division, there's no division. Addition, yes, I have the 10 plus 98, that's 108. I have my final number, and there it is. Let's take a look at some other examples. One very important part of this PEMDAS is that multiplication and division are handled left to right as they appear. Sometimes you might actually do division first. And addition and subtraction are also handled left to right as they appear in the expression. Here's an example. Take a look at 12 divided by 2 times 3. It only has division and multiplication, so I take those left to right. The first thing I do is 12 divided by 2, and that's 6. And then 6 times 3, and that gives me 18. In this middle expression, it's kind of the same thing. If I did the parentheses first, that'd be 12 divided by 2 is 6, and then times 3 is 18. So the parentheses are really optional here. However, if I wanted to force the multiplication to go first, I really do need parentheses. And so this expression becomes 12 divided by, now evaluate 2 times 3, that's 6, and 12 divided by 6 is 2. Honestly, we almost never see this division symbol here. We're always going to see expressions like 12 divided by 2 times 3, like that. Typically the dot for multiplication and the fraction bar to indicate division. How about this next example? Can you see what that will be? Well, addition and subtraction are handled left to right, so I first do the subtraction. 12 minus 2 is 10, so 10 plus 3, and now I do the addition. 10 plus 3 is 13. The last expression, can you handle this one? Maybe pause the video if you want to give it a try, and then when you're ready, start the video up again and check your answer. Let's take a look. We have nested parentheses, so I'll go inside the deepest level and handle that first. So 10 minus 8 is 2. So 5 minus 7 times 2 plus 2 times 2. All right, now I'll still keep working inside my grouping symbol. It's brackets, but that's okay, parentheses. I have 7 times 2 is 14. So 5 minus 14 plus, and now the next multiplication, 2 times 2 is 4. And now I get, let's evaluate inside the brackets. That looks like 18. So 5 minus 18. And that is negative 13. And that might be a situation where you need to use a calculator, and that's fine. Rational expressions, or in other words, fractions. How do we handle basic fractions? So when multiplying fractions, we multiply straight across. So numerators multiply with numerators. We get 1 times 3. Denominators multiply with denominators. 6 times 7. And we get 3 over 42. Now, maybe you notice that this fraction isn't in lowest terms. It can be reduced. And I can see early on how to reduce it by seeing that 3 and 6 have a common factor of 3. When I divide the 3 out, that becomes 1, the 6 becomes 2. So I could have written this as 1 times 1 over 2 times 7, 2 times 7, in which case I'd get 1 over 14, and that's the reduced fraction that is the answer to this problem. Now, 5 times 2/7, the trick is, remember that the number 5 is really 5 over 1. So 5 over 1 times 2 over 7, and that gives me 10 over 7. A lot of times when you get comfortable with these things, 7 times 3 over 4, you just take, if there's a single number out front, and multiply it with the numerator of the fraction, and that'll give you the answers. 21 over 4. There we go. Now, when adding or subtracting fractions, we have to find a common denominator. We need to find a denominator that is a multiple of both of those that are given to us. So what is a multiple of 4 and a multiple of 7? A good trick is this fraction that has 4 on the bottom, multiply it times 7 over 7. And the fraction with the 7 on the bottom, multiply times 4 over 4. That's guaranteed to give us a common denominator. So the fraction on the left becomes 7 over, 7 times 4 is 28. The fraction on the right, 2 times 4 is 8, and 7 times 4 is 28. Add them together. Now only the numerators add. 7 plus 8 is 15, and that denominator stays the same, 28. It's like I have 7 of something plus 8 of something, and I end up with 15 of that thing. I have 7 28ths, and I add to it another 8 28ths, and in total I have 15 28ths. How about the subtraction problem? I could do the same trick as before and multiply the left times 30 over 30 and multiply the right times 20 over 20, but maybe you notice there's an easier way. The denominators, the 20 and the 30, they're both factors of 60, so I can just multiply times 3 over 3 on the left and multiply times 2 over 2 on the right. So the left fraction turns into 3 over 60, and the right, whoops, not plus, how about minus? The right fraction becomes 7 times 2 is 14 over 60. And now subtract the top. 3 minus 14. That's negative 11. And the 60 stays the same. You can leave the fraction like this, negative 11 on top and 60 on the bottom. Alternatively, you can put the negative out front. So negative 11 over 60 is the same thing as negative 11/60. And there we go. One more example with rational expressions. Dividing fractions. So a over b divided by c over d ends up being a over b times d over c. This fraction that's on the bottom comes up, becomes multiplying, and it gets flipped around. Like it does a little gymnastics backflip before it appears there. This is called the reciprocal. So dividing by a fraction is the same as multiplying by its reciprocal. Here's an example. 7/15 divided by 5/6. I would write this as 7/15 times 6/5. I take the reciprocal of the bottom. And now it's multiplication. I multiply across the top, 42. I multiply across the bottom. Say 15 times 5 is 75. And we have our answer there. Is that reduced? Actually, no. When I look back here, I think the 6 and the 15 have a common factor of 3. So when I divide 3 out, that becomes 2, and when I divide 3 out, that becomes 5. So I could have written this, 7 times 2 is 14, and 5 times 5 is 25. And there is our fraction in lowest terms. How about this guy? Well, I need to do a little bit of work before I divide fractions. 1 is the same thing as 3 over 3, so 3/3 plus 1/3, that's 4/3 on top. And 3 times 5 halves, oh, I can just take the 3 times 5. That gives me 15 halves. Now let's take that fraction on top, 4/3, and I'll multiply times the reciprocal of the denominator, 2/15. At this point, maybe I'll think ahead a little bit. Can I reduce anything? The 2 and the 3, they don't have any common factors. The 4 and the 15, no common factors. I think this is already reduced. All right, so multiply straight across. 4 times 2 is 8, and 3 times 15 is 45. And there is our fraction in lowest terms. One last example. How about this 10 over 5/6? Well, I can take that 5/6 and bring it up and call that 6/5. And now I could multiply 10 times 6 and get 60, but maybe you notice there are some common factors between 10 and 5, and so that's going to reduce to 2 and 1, so it looks like a 12 over 1, which is just 12. All right, so there are some examples with dividing fractions. Let's move on to working with properties. In particular, the distributive property. This distributive property appears again and again and again. It shows us how to relate multiplication with addition or subtraction. I guess I could put a minus in there, plus or minus. And it tells us that if I have b plus or minus c, and that's being multiplied by a, I can distribute the a across the two. So a times the quantity, b plus c, is a times b plus a times c. And the distribution property works if your single factor is multiplied on the right as well. Some examples here. 6 times the quantity x plus 1, 6x plus, let's see, 6 distributes to the x, 6 distributes to the 1, 6 times 1 is 6. C times the quantity c minus 7, c times c minus c times 7. That c was distributed across the subtraction. And we usually call c times c, c squared. And c times 7 seems a little bit weird. Just purely out of tradition, we generally put the number first. So we call that 7c. There we go, c squared minus 7c. Here's an example where I am distributing from the right. I'll take my y times 4 and the y times x. So I end up with 4y minus x times y. And how about this last one? 3 times 4x plus 3 times 10z. And then I can multiply the numbers together to make it look a little nicer. 12x plus 30z. One kind of distribution that occurs a lot is distributing a negative. Putting a negative in front of a quantity really is the same thing as a -1. It's like multiplying times a -1, so it's like distributing a -1, but we often see it as a negative, so let's do some examples of that. Negative, the quantity 2 plus x, is -2 minus x. Negative, the quantity x minus 7, is -x plus 7. How about this guy? I'm going to have to do a couple distributions, I think. Let's distribute the minus across the plus here, so that gives me -5 minus the quantity x minus 6. Oh, but now I need to distribute again. This is -5. Now when I distribute this minus x plus 6. Minus x plus 6. Now I can do a little bit of simplifying. You see I have a -5, or you could call that a -5, and a plus 6. How do a -5 and a plus 6 combine? That gives me a +1. So I can call that just simply 1, and I have a -6 remaining. X remaining. 1 minus x, right there. As our last example of distribution, sometimes we need to do a double distribution. Now, if you've seen FOIL already, you know this, but you don't have to think about it as some trick. This really is just distribution. Let's take our x plus 3 and think of that as just one kind of unit that gets distributed across the x plus 4. And so I end up with x plus 3 times x plus the quantity x plus 3 times 4. And now here's the second distribution. I need to distribute the x times x plus 3. I get x squared plus 3x plus, now distribute the 4 across x plus 3, 4x plus 12. And that's the correct answer. That's fully distributed. I do have some simplifying I can do. There are like terms, 3x and 4x. I can add those together to get 7x. So maybe my final answer for this is x squared plus 7x plus 12. That looks good. All right, last example. Let's be very careful with our minus signs here. Again, I'll take this x minus 1 and think about distributing that across my x minus 9. So I get x minus 1 times x minus x minus 1 times 9. All right, so in this first case, I'll distribute the x across, and I get x squared minus x. Now, minus this guy, maybe I'll simplify this expression before I distribute my minus. Let's simplify that. That becomes 9x minus 9. So minus 9x minus 9, like that. Now I can distribute the minus across, and I get x squared minus x minus 9x plus 9. Do I have any like terms? I have a minus x and a minus 9x. So I have a minus 1 and a minus 9 is going to give me minus 10. So x squared minus 10x plus 9. There is my answer. And that ends our first lesson, Unit 1 on the real numbers.